Hey guys, so I've got another code challenge for you. And this one, as the title suggests, this is a difficult challenge. And this is something that I expect some of you might need to spend 15-20 minutes on, others might need to spend 30-40 minutes on, and it might just be something that you need to have a think about, get stuck, come back to it after a bit of a break, or sleep on it, come back to it the next day. It's not easy, but what I'm trying to say is really give it all you have before you check the solution video, because it's a really interesting challenge. So the idea is that we want you to write a program that works out whether if any given year is a leap year. We know that a normal year has 365 days, but leap years have an extra day in February. And the reason is actually really interesting. If you're interested, there's a really good explanation of how leap years work and why we have them at this YouTube link. So just go ahead and copy this URL and check it out. Now, the way that you work out if a given year is a leap year, so let's say we pick one out of thin air, 2020, is that on every year that is evenly divisible by 4, so that means divisible by 4 with no remainder, then that is a leap year. But except the years that is also evenly divisible by 100, unless the year is also evenly divisible by 400. Now, 2020 divided by 4 is equal to 505. So it's evenly divisible by 4. There's no remainder. But the rule says that even if it's divisible by 4, if it's evenly divisible by 100, then that is still not going to be a leap year. So let's try that. 2020 divided by 100 equals 20.2. So this is in fact not evenly divisible by 100. So that means it is still a leap year. But then it says unless the year is also evenly divisible by 400. So 2020 divided by 400 is not evenly divisible. So it is in fact still a leap year. The trickiest part of this entire challenge, I would say, is getting your head around these 3 sentences. A year that is divisible by 4 with no remainder is a leap year, except if it's also divisible by 100. In that case, it's no longer a leap year, unless that year also happens to be evenly divisible by 400, then it is still a leap year. What I recommend doing is if English is not your native language, then have a look online for the rules for determining a leap year in your own language, because these words, except and unless, are so integral to how this algorithm works. And you really need to understand exactly what it means. Then what I recommend you doing is to go ahead and create a flowchart, just like what I've done in previous examples. Head over to a website like draw.io, or simply just write it on a piece of paper. Draw it out and visualize what this actually means in terms of your code. Now, if you really get stuck on that, I've also created a flowchart for you. So if you actually get stuck creating the flowchart, there is one there that you can refer to as well. But it's a really good exercise creating your own flowchart based on what it is that you want your program to do. And your algorithm or your code should correctly tell us whether if it's a leap year or not a leap year. So it just has to print out leap year if it is, like 2400. And if it's not a leap year, like 1989, then just print not leap year. This is the time to pause the video and really give this challenge everything you've got. I'll see you back here once you're done. All right, so how did you get on? As I mentioned, this is a really difficult challenge. If you haven't managed to solve it, then try to come back to it a little bit later on and spend more time on it. This is a decisive moment. Don't give up on yourself. Keep going. I'm always going to be here for you with the solution. You're not going to get stuck. It's really, really important to try and solve it yourself. Now, the first thing I mentioned is turning this rule for determining whether if a year is a leap year or not into a flowchart. So I've created one which I linked to in the challenge, and it's very simple. We start off by asking ourselves, is a particular year that we have in mind, let's say the year 2000, is it cleanly divisible by 4? Which means, can you divide it by 4 with 0 remainder? Well, if the case is no, then it's already definitely not a leap year. But if the case is yes, then we have to ask ourselves some more questions. Namely, can we divide it by 100 with no remainder? Well, if we can't, then it's definitely a leap year. But if we can, then we have to check yet again. Can we divide it by 400 with no remainder? If the answer is yes, then it's a leap year. If the answer is no, then it's not a leap year. Let's try and code that logic out. Keep your flowchart up somewhere so that you can write your code while referring to the diagram. We start off by checking whether if the year that came in through the input is divisible by 4 with no remainder. And you might remember from our previous code exercise that the way we do this is using the modulo. So year modulo 4 will give us the remainder. So if the remainder is equal to 0, well, in that case, it's cleanly divisible by 4. And you can check this out yourself in the console. Let's say if you have 8 modulo 4, 4 goes into 8 cleanly, there's 2 4s in an 8, the remainder is 0. Whereas 9 modulo 4, 4 plus 4 is 8, remainder 1. So if the remainder from the year divided by 4 is equal to 0, then it is cleanly divisible by 4. So in this case, we'll have to go into yet another if statement. But if it's actually false, then it's definitely not a leap year. So the else statement that matches this if statement is going to tell us for sure that this is not a leap year. But if it is true, then we have to check the next thing. Is it cleanly divisible by 100? So we check if the year modulo 100 is equal to 0. And if the answer is yes, then we have to check that year against another question. But if it's no, then it's definitely a leap year. In this case, that will lead to an if statement if it's true. But if it's false, then we can simply print leap year because that's what it's going to be. The final question that we have to ask ourselves about the year is it cleanly divisible by 400? So now if year modulo 400 is equal to 0, well, in this case, if it is true, then it's definitely a leap year. If it's false, then it's definitely not a leap year. So we can print leap year if it's true. Otherwise, or if it's false, then we can print not leap year. And that's it. That's all the code that you would need in order to represent this logic. Now, there's plenty of other ways that you could have written your code, but this is probably the most readable. Now, if you've written some different code, but it still uses these rules to work out whether if a given year is a leap year and it's correct, then that's fine as well. There's plenty of ways that you can solve this challenge. The most important thing I want you to take away from this code exercise is that you can turn any sort of logic into a flowchart to be able to visualize it. And once you've got your logic straight, then converting it into code is much, much simpler. If you haven't figured out the logic and then you try to start writing code, then it's going to be a mess. So first, get to the stage of being able to create your own flowcharts and then take those flowcharts and turn them into code. If you got stuck on this challenge, or if you didn't manage to complete it for some reason, head back to it now and give it some extra attention, because this is really, really important. It's in these moments, these code challenges, where you're actually going to level up as a programmer. It's not during the tutorials, it's not during the videos where I explain things to you. It's where you actually write the code yourself. I hope you had fun on this code challenge and you managed to complete it, be it with hints or without hints. On the next lesson, we're going to take the if statement one step further, and I want to show you how you can have multiple if statements and test for multiple conditions. So for all of that and more, I'll see you on the next lesson.